In this video, we're going to learn how to derive the addition formula in trigonometry. Now first you need to know that if you had a sine squared theta plus a cos squared theta, that is equal to a 1. And also you need to know that there is an equation called as the Pythagorean equation, that if you had a hypotenuse side and squared of that hypotenuse, that will be equal to the opposite plus the adjacent all squared. Or rather, I should say squared individually. That is the opposite squared plus an adjacent squared. Now you can only use this equation if you had a right angle triangle. So you just need to hold that at the back. Now you would also need to understand that there is another equation that is called as the sine rule. So if I had a triangle and I wanted to find the sides of each side, that is going to be sine A, and sine A is going to be equal to sine B. Well, so I need to rewrite this. This is going to be equal to sine B divided by B. That will be equal to sine C divided by C. And lastly, you need to know this one. If you had something like that, let us say you had a triangle such as this, and let's say this is a side A, this is a side B. Sorry, those are angles actually. Now this is going to be the side A, that is a lowercase a. This will be the side C, this is going to be the side B. So I could try to find out what is going to be one of the sides of this triangle by the use of the cosine rule. Now let us say I just wanted to find out what is going to be the side A. The cosine rule could leave me there. So that will be a squared, and a squared will be equal to b squared plus a c squared minus 2bc cos the angle that faces up the side A. Now this is the side A. The angle that faces it is this. So that is going to be an A. Now I could also write it in terms of a B. If I wanted to find the side B, that will be b squared. B squared is actually going to be equal to a squared plus a c squared. That will be minus 2ac cos a b. That is the angle B, this angle. Now lastly, I could also try to find out what is the side C. That will be equal to a squared plus a b squared. That will be equal to 2ab cos c. So these are the three forms that you could actually express this rule. This is actually called as a cosine rule, and it's very important. So if you understand this group of laws or equations, and you know how to use them so well, using the right angle triangle, and we could well find out what this addition formula is actually going to look like. So let us jump right into it. I need to wipe this stuff out. So first, let us say that this is a triangle. I just hope the triangle is as nice as possible. And let us say that I'm just gonna take it a little bit lower now. Here. And let us say this is the angle A. I'm gonna rewrite it. This is the angle A, and let's say this is the angle B. Let's call these the angle C. So what I'm going to do is I would actually bisect this triangle from this angle to this place. So here I'm just going to say this is a bisector which actually divides the side BC into two equal parts. I think I need to draw this line again. So let me try that. Something like this. Do it again. Yeah. Now let us say this angle has been bisected into alpha and into beta. And let us say this line is actually the height. of the triangle. So BC, let us say this has been divided into X and Y. Let's say this is the side Z. Let's say this is the side W. Now, from Pythagorean theorem, you could say that cos alpha, which you know that is adjacent, divided by hypotenuse. The adjacent to the angle alpha, that is actually the h. So that should be h divided by the hypotenuse with respect to this right angle triangle. That is going to be a z. Now, if I wanted to find out what is going to be the sine of the alpha, that will be equal to opposite. That is divided by the hypotenuse. Now, the opposite to this angle, that is the side that faces the angle, and that is clearly going to be an x. Now, the hypotenuse again, that will be a z. How about finding the cos of beta? Now, the cosine of a beta, so in this case, I need to take note of this side of the right angle triangle. So we know once again that should be adjacent divided by the hypotenuse in it. So in this case, the adjacent for this angle, that is actually h. And we need to divide it by the hypotenuse, which is actually w. So I need to write that better now. Whoa. So that is what you got. Now, if I wanted to find sine or beta, that will be opposite, which is a y, divided by the hypotenuse, which is a w. So you got this 4 forms from the Pythagorean theorem. Now, first thing I'm going to do, I would actually use the sine rule. Now, in this case, I know that I could have a sine A divided by A, and that is equal to sine B divided by B. That will be equal to sine C divided by C. Now, notice that A, that is actually the angle within this position. Now, this angle has been bisected into this angle alpha and beta. So I could call A as A plus beta. So A is actually equal to, well, alpha plus beta. So I think I need to wipe this stuff out. Hopefully by now you understand the point. We're going to use it later on. So in this case, we have a sine alpha plus a beta. This will be divided by A. Now, what is A? Obviously, you should know that if we had an angle as this, and let's say this is an A, this point is actually going to be the A part of this triangle. That would stand for this side that faces the angle A. And so in that case, this whole part, that is actually the side A. So that will be BC. So I'm just gonna write it that way. That is a BC. Now this obviously is equal to sine B. So I'm just gonna leave out sine C divided by C in this case. I will just work with the 2 ones. So this will be sine B. Now sine B is actually the sine of this stuff. So I'm just gonna leave it as a sine B. This will be divided by a B. Now B, obviously, if we said this is the side B, this should be, well, if we said this is the angle B, rather, this is going to be the side B. And so that is going to be the side AC. We know that side B is the same thing as a side AC. So that is going to be side AC that way. Now, from the Pythagorean theorem, if we extrapolated this triangle and had something like this, and let us say this is the angle B, we know that this is the height, this is Z, which is actually the longest side, and we also have the X here. If we wanted to find the sine of B, Sine is equal to opposite divided by the hypotenuse. So this is the angle B. The opposite to the angle B is a side H. So I need to write it as the H. Now the hypotenuse is a Z. So that should be a Z. That means sine B is equal to H divided by Z. Next up, we need to find what BC is going to look like. Now BC, that is this side. This stuff which you see here. That is the length BC. Now we know that BC has been divided into X plus C. Sorry, X plus a Y rather. So that is going to be X plus Y. Now also we have a place where we need to plug in AC. Now in order to do this, you know that AC is this part. So obviously that is going to be a W. So what I'm going to do is plug in all these values into the stuff that we got. So I'm going to take it a little bit upper now. Take it upper again. So this is going to be sine alpha plus a beta. This will be divided by BC, which we said in this case BC is going to be X plus a Y. Now sine B is the same thing as H divided by Z. This will be divided by AC, which is a W. And that is what you got. So I think I'm going to wipe all these out. Now what I'm going to do is this stuff, I would actually rewrite it. That typically should have a Z run downwards. So you're going to have something like this. So this will be X plus Y, and here we're going to have a H divided by ZW, or a WZ. Next up, I want to cross multiply using X plus Y. So what is that going to look like? So I'm going to have a sine alpha plus a beta. That will be X multiplied by, H multiplied by X plus a Y divided by WZ. Now if I wanted to FOIL this bracket, that is going to be H multiplied by X. That is going to be HX plus HY. This is all divided by WZ. Now if I had an A plus a B divided by a C, I could well split this stuff into A divided by C plus a B divided by C. So that is exactly what I want to do with this stuff. So in this case, we're going to have a sine alpha plus a beta. That is HX divided by WZ plus a HY divided by WZ. Now in this case, I'm going to go back to the original stuff that we said before now. So I need to scroll these a bit lower now. Take this down. Now from this point, we need to bring out some parameters. First, I know that if I wanted to have a cos alpha, I think I'm going to take it lower now. I'm going to write it here. If I want to find what is a cos alpha, this is alpha, and we know cos is equal to adjacent divided by hypotenuse. Now the adjacent side to the angle alpha is actually H. So that will be H. And then we have it as divided by adjacent, well, divided by the hypotenuse rather. So that will be a Z. Then you have a sine alpha. So this is actually going to be equal to opposite divided by the hypotenuse. Now the opposite to it is the X. You have the hypotenuse, that is a Z. Now let us try to find out what cos beta is going to look like. So we know cos is adjacent divided by the hypotenuse. So this is cos. Now the adjacent to it is on H, divided by the hypotenuse, which is actually a W. And here we have a sine beta. So this is actually the opposite, which is a Y, divided by the hypotenuse, which is a W. So we need to hold these ones at the back. It's going to be very useful. I think I'm going to hold this. All right, these are. Now this is what we got. Notice that here we actually have something like h divided by z. That is something reasonable, isn't it? Now we also have an h divided by w, right? We have an a divided by w and y divided by z. Now we also have an x divided by z. So let us take it that way. If we took an h divided by z, that will give us the cos alpha. But there is no x divided by w from this catalog of trigonometric identities. So what we're going to do is go with the ones that we have. So first, we have I'm going to use h divided by w. That will be multiplied by x divided by z. And we have an h divided by z. That is this stuff. We have it. And we also have a y divided by w. And the reason I need to use that is, although we have an h divided by a w here, that is a cos beta. We do not really have a y divided by a z. So we just need to flip this off. So here we're going to have a h divided by a z. That will be multiplied by y divided by a w. So that is what you're going to have here. So sine alpha plus a beta will be h divided by w. Now h divided by w, that is cos beta. So I'm going to rewrite it there. That will be multiplied by x divided by z, which is a sine alpha. Then you have a h divided by z, that is cos alpha. Then you have it as multiplied with a y divided by a w, which is a sine beta. So this is going to be what you're going to have. So I can rewrite this. Let me rewrite it. So this will be sine alpha cos beta plus cos alpha sine beta. So this is actually the first addition formula. And you're going to have another type of it if you wanted to have it as a negative. So if I wanted a sine alpha minus a beta, it's going to be simple. I think I need to write it a little bit lower now. So that is sine alpha minus a beta. That is going to be sine alpha cos beta minus cos alpha multiplied by sine beta. So these are the two equations that you would actually need for sine. Now we need to find out the ones that will be for cosine. So let us see what these are going to look like. So right now I'm just going to take these ones out. We're going to try and find the other ones. So I think I'm going to take these back now. Wipe these ones out. Now you need to know that we could also have the cosine rule to be used. So which cosine rule are we going to use? The first one we got is you could have a squared is equal to b squared plus a c squared, and that will be a minus 2bc cos and a. You could also have it as a b squared. So I need to rewrite this too. That will be equal to a squared plus a c squared, yeah, minus a 2bc, well, that should be 2ac cos of b. You could also have a c squared. That is going to be equal to a squared plus a b squared minus 2ab cos of c. Now, which one are we going to use? So we're going to use the one that relates with something like this, with the angle, because we are more interested in the angles. So let us choose the one that has to do with this angle. So that clearly is going to be this one. We're going to go with this one. So we got a squared that is equal to b squared, well, plus a c squared minus a 2bc cos a. Now we already know what a is. A is actually the, so what is a? A is this stuff. We got x plus y. That is going to be a. But we got a squared. So there should be x plus a y. And that should be a squared. Now for the b, the side b, we know that is this side. And so that should be a w squared. The side c, that is the side that faces the angle c. And that clearly is the z. So we're just going to write that as a z squared. And this will be minus 2b. So we know b is a w. And we know c, that is a z. And then we have cos a. Now you already know that a is the same thing as alpha plus a beta. So I really need to write that out. I'm going to take it a little bit upper now. Yeah. So here now we should have a x plus a y squared. That is equal to w squared plus a z squared minus a 2w z cos a. Now we know a is the same thing as alpha plus a beta, so we need to rewrite that there. So what I'm going to do next up is take this part of the right hand side and take it to the left, while I'll take this to the other side. So that is going to be 2wz cos alpha plus a beta. This will be equal to w squared plus a z squared. And here we're going to have a minus x plus a y. That will be squared. So that is what we got. Now in order to isolate cos alpha plus beta, I need to take this away from it. So we're going to have a cos alpha plus beta. That will be equal to, that should be equal to w squared plus a z squared. This will be minus x plus a y squared. This will be divided by 2wz. Now we need to try to FOIL this bracket. So let us take it out now. So as usual, I'm just going to take these out for the sake of space. We're going to formulate around. So here now we got cos alpha plus a beta. This is going to be equal to w squared plus a z squared minus x plus a y multiplied by x plus a y. So this will be divided by 2wz. Now we need to try to work this. So first we're going to take x and multiply with x. Later on we're going to take x and multiply it with a y. And we're just going to do pretty same thing with a y. So y multiplied by x and y multiplied by y. Now that is going to give us a cos alpha plus a beta. That will be equal to w squared plus a z squared. And here we're going to have something like this. So first we have a x multiplied by x. That is x squared. And we have plus xy plus another xy. That is y multiplied by x. That will give us an xy. Now we have plus a y squared. So that is what we got there. This is all divided by 2wz. So here now we got cos alpha plus beta. And that is equal to w squared plus z squared minus x squared plus a 2xy minus a y squared. This is all divided by 2wz. Now I'm going to use this negative to try to FOIL this bracket. So this is what we're going to have. So this is going to be a negative x squared, and we're going to have a negative 2xy, a plus y squared. This is all divided by 2wz. So I need to take these out, 2wz. Now, we need to work some stuff here. So let us see how we're going to do it. Now, first off, if we took this part of the triangle, we're going to create a right angle triangle. So this is h, this is z, this is an x. So we know that z squared is equal to h squared plus an x squared. So if I wanted to find an h squared, that is going to be z squared minus an x squared. That will be equal to h squared. We need to hold these at the back. Now let us try something else. What if I made this other the right angle triangle? This is h, this is y, and this is the w. Now we know that w squared, that is going to be equal to h squared plus a y squared. So if I took this to this other side, I'm going to have the h squared. So w squared minus a y squared, that is equal to h squared in it. So I need to hold that also at the back. Now we're going to make some work from here. Now remember, we have that. Well, so I really made a mistake here. There should be a positive here. Sorry, a negative rather. This is actually negative. So if I rearranged this stuff, this is going to be alpha plus a beta. This will be equal to w squared. And we have a w squared minus a y squared. So I'm just going to place that there. We also have a z squared minus an x squared. So I would also place that there. That is plus z squared minus an x squared. We have a minus x squared, this stuff. Now we're also going to have a w squared minus a y squared. Remember, from that expansion, we should actually have had x squared plus a 2xy plus a y squared rather in it. Now if we took a minus 1 to FOIL the bracket, we should have minus x squared minus a 2xy minus a y squared. So there was actually a mistake where I said it should be a positive. That wasn't correct. And so if we took this and this, that means we have taken this and this. And we also have taken this and this. So we just got a negative 2xy left. So this is minus 2xy. This will be divided by 2yz, 2wz rather. Okay. Now we know that, as you can see from this place, z squared minus x squared, that is written as an h squared. So this stuff is going to change to an h squared. And also we got w squared minus a y squared. That is also equal to an h squared. So that should be a cos alpha plus a beta. That will be equal to the h squared. And here we're going to have plus another h squared. And this will be minus 2xy. This is all divided by 2wz. So obviously we know this is going to give us a 2h squared minus 2xy. This is all divided by 2w squared. Now, we know that we could factor 2 out of the numerator part of that fraction. So we're going to have a 2 into h squared minus an xy. This is all divided by 2wz. Now this stuff is going to cancel. This would cancel these out. So we should just have h squared minus an xy all divided by wz. Now as usual, I'm going to split this off. So I should wipe these out now. So we got cos alpha plus a beta. That will be equal to h squared divided by wz minus an xy divided by wz. Now from here we could make this to be as h multiplied by h. So that will be cos alpha plus a beta. That will be equal to h multiplied by h divided by w multiplied by z. This will be minus x multiplied by y divided by w multiplied by z. Now we need to go back to what we said initially using this triangle. There were some trigonometric functions that we derived from these. First, we said that if you wanted to have a cos alpha, that would be adjacent, which is the h, divided by the hypotenuse, which is the z. Then if you wanted to find the sine alpha, that will be opposite, which is the x, divided by the opposite, which is a z. Then if you wanted to find the cos of the angle beta, that should have been the adjacent, which is an h, divided by the hypotenuse for this triangle. That gives you a w. And trying to find out the sine of the angle b, or beta rather, that will be opposite, which is the y. And that is actually divided by the hypotenuse, which is the w. So we just have these stuff at the back. We really need to use them. So first off, we know this is going to be, we have h divided by w. Fortunately, we have that here also. There is also an h divided by z. We also have that here. And we also have an x divided by z. This stuff. And we happen to have a y divided by w. That is going to be sine of beta. So let us combine them and see what that is going to give us. So first we have a h divided by a w. That was written here as a cos beta. So that is going to be a cos beta. That would obviously be multiplied by cos alpha. That is a h divided by a z. So that is going to be a cos alpha. So that is cos alpha. Then we have a x divided by z. Now x divided by z, that was given as a sine of alpha. And then we have a y divided by a w. So that should be sine beta. So that is what you have. So from here we can see that we have something really nice. So I think I'm going to wipe everything out on this side now. So we can see that we got cos alpha plus a beta. And that is equal to, I'm just going to start with cos alpha multiplied by cos beta. That is a plus sine alpha sine beta. And we could also find the cos of the alpha minus the beta. And that would give us a cos alpha cos beta minus sine alpha sine beta. Now remember from the first part of the video, feel free to rewind and see where just where we found that. We found that sine alpha plus a beta, that is equal to sine alpha cos beta plus cos alpha sine beta. And we also had a sine alpha minus a beta. That was written as a sine alpha cos beta minus cos alpha sine beta. Now the question is, what is going to be tan? What is going to be tan alpha plus a beta? How we going to find it? And the best thing to do is to remember that if you have a tan, that is actually a sine of the alpha plus the beta divided by the cos of the alpha plus the beta. So we need to take the formulas for the sine alpha plus beta divided by cos alpha plus a beta. So let us take that in. So this is going to be tan alpha plus a beta. Now sine alpha plus a beta, that is actually sine alpha cos beta plus cos alpha sine beta. So this will be divided by cos. Now we know that for cos, we should have a cos alpha cos beta minus sine alpha sine beta. Now, there is something else that we can do from here. I'm going to take this part of the denominator and divide through this whole equation with it. So what I'm going to do is I'll divide the numerator with this stuff and the denominator with this stuff. So this is what I mean. We got tan alpha plus a beta. That is going to be sine alpha cos beta. So I'm just gonna go gradually now. So this will be all divided by cos alpha cos of beta. Then divided again by cos alpha cos beta minus sine alpha sine beta. This again all divided by cos alpha cos of beta. Now we know that from here, it is very possible to split these fractions. I could well have this divided by this plus this divided by this. And the same thing is going to happen for the denominator. So this is what we should have. This will be sine alpha cos beta divided by cos alpha cos beta. And this is plus cos alpha sine beta divided by cos alpha cos beta. This would now be divided by cos alpha, so I made a mistake there, cos of beta divided by itself, that is cos alpha cos beta, and this will be minus sine alpha sine beta divided by cos alpha cos of beta. Now from here we can see that cos beta is going to cancel this, and we're going to have cos alpha cancel cos alpha on top, and here we're going to have the whole stuff get cancelled. So we would have something like this, this cancels. And so I think I'm gonna wipe these out now. Now if you have sine divided by cos, that should give you tan. So that will be tan alpha. Now if you had a sine beta divided by a cos beta, that should give you tan beta. Notice that this cancelled out with this. So we're going to have it divided by a 1, because this is going to give us a 1. Now here we have a sine alpha divided by a cos alpha. That should give us a tan alpha. And this will be multiplied by sine beta divided by cos beta. So that should give us a tan beta. So that will be the answer for tan alpha plus a beta. So we have this, and also we have that tan alpha minus a beta. That is going to be tan alpha minus tan beta. That will be divided by 1 plus tan alpha tan beta. So this is basically it. This is how to find all the addition formulas that are actually present within trigonometry.